Hello everyone, so our project name is Traffic Light Controller using CPLD. The board which we are using is a Krypton V1.2 board. So let us take a look upon how does the code work. So the software which we are using is a Cortex 2 software. So let us see how does it works. So this is our software. In this software, first we have our module traffic main. This module is responsible for controlling the traffic light at a four-way intersection. It takes input for each direction, north, east, south and west, as well as the inputs for clock and reset signal. uh, then we have state variables. We declare two register variables, that is state and count. State keeps the track of the current state of each traffic light, whether it's green or yellow. Count is a counter used to manage the timing of the state transitions. Then we have parameter declarations. We define parameter for different state of traffic lights. For example, north green, north yellow, south green, south yellow, which represents the green and yellow states for the north direction and south direction, and etc. State state transition logic. Inside the always block, we use a case statement to handle state transitions for each direction. For instance, if the state is not green, we check the count. When the count reaches a certain value, we transitions to north yellow state. Otherwise, we keep counting to maintain the green state. And the output logic is we use other another always block to set the outputs for each direction based on the current state. For example, if the north light is green, we set the output accordingly to simulate the traffic light. Overall, the code simulates a basic traffic light system. Now let us check the pin assignment. So for pin assignment, we have to go to the pin planner. The pins assigned for this board are pin 18, which is 1 megahertz internal clock. So we have given here the internal clock, and these are all the north, east, north, south, west directions. For each red, yellow, green, we have assigned a pin. The pins are this. These are the pin mapping for header 0. We have given the output pins on the header 0. So for pin number 2, we have given the red east, and for 4 yellow east, and green for 6. Accordingly, we have given every direction pins on this board. After assigning the pins, let us compile the code and create a SVF file. Close this window, then go to processing, start compilation. Your compilation takes place. As we can see, there are 0 errors in the code. That means our code is successfully compiled. For creating SVF file, we have to go to programmer, then file, create jam jbc svf or isc file. So we want your svf file and give a name. Suppose I am giving your name traffic main1.svf, then OK. Now our svf file is created on our saved directory. Let us check. This is my Altera directory here. Let us check if our svf file is successfully created or not. As we can see, our file is successfully created here. Now we are ready to upload the file on our Krypton board. Before uploading the code to the board, let us check our simulation for the code. For simulation process, we have used software Vivado. Let us check. So this is our software Vivado, and this is our code here. Now let us run the simulation. Let us run. As you can see here, the lights are successfully changing its state. That means our simulation is successfully done. Now let us upload the code. For uploading the SVF file to our board, we require a JTAG shell. So first install the JTAG shell. After installing, search here JTAG. Then a shell script will open. Then connect your USB cable to the board. Then type your F cable FT2232. Here it connects our cable to the board. Then we have to upload the BSDL path. That means we have to upload the board components, board parts to the JTAG to identify our board. Copy the BSDL path and paste it in the shell. Hit enter. Now we have to detect our board. For detecting, type detect. Here our board is successfully detected. Now we are ready to upload the SVF file to the board. Now type your SVF and our SVF file destination. Copy the destination path and paste it here and hit enter. It is uploading the code. Wait for the shell to end. As we can see, JTAG is written there. That means our code is successfully uploaded, and now we are ready to assign our LEDs to our output pins that we have planned in the pin assignment. Now connect the LEDs to the assigned pins. Here I have already created a traffic light signal models and connected all the LEDs to the assigned pins. Here it is.